Hey guys! So today we are finding the hypotenuse from the Pythagorean Theorem. So we need to be on page 13 in your math workbook, so turn to that page please. We're going to take some notes together all about the Pythagorean Theorem. Okay, so there are three sides of a triangle because that's what makes a triangle a triangle. Now each of the sides have special names. There's a side A and a side B, and then you have your side C. A and B, they can be either A here or B here or B here or A here. They can switch. And they are called the legs. They're the legs of the triangle. And this side over here, this side C, is always the hypotenuse. So we're going to write down that crazy sounding word. Hypotenuse, the hypotenuse. It's kind of like hippopotamus-ish, but not really. Anyways, the hypotenuse. Okay, so this is a right triangle, and I know that it's a right triangle because there's this 90-degree angle, and every right triangle has a 90-degree angle. And if we're looking that it, stop! Why did you do that?
You didn't tell them to do it.
Oh, there it goes. Hey guys! So today we are going to be in our workbooks. Happy day of online learning. We're going to go to page 13. So that's it right here. 1, 3. Everybody turn to page 13, please. Yay. Love it. Okay, great. So we are going to be talking about the Pythagorean Theorem, and we're going to be solving for the hypotenuse. Okay? So we're going to talk about all of those things in just a second. There are parts of our triangle. Each triangle has 3 sides. That's what makes it a triangle. We have side A and side B and then side C. Side A and side B can go back and forth, like this could be B and this could be A, and it's totally fine. And these guys are called legs. The longest side is side C, this long guy over here, and we call him the hypotenuse. Hypotenuse. I'm brilliant, right? It's also written right there. Okay, anyways. This guy is a right triangle, and I know he's a right triangle because he has this little right symbol. And if we remember, this right symbol means that he is worth 90 degrees. So there's 90 degrees in this angle. The Pythagorean Theorem only works for right triangles, so it's special. Now, if we draw a tail from this right angle, this tail now makes the shape of an arrow, and the arrow always points to side C. So this side C is very special. The hypotenuse, we need to remember it always. And again, if you forget which one is side C, it's the longest one, and it's the one across from the right angle. Okay, so let's do some examples, again, on page 13. Notice that your triangles are all nice and blank. Yeah, we're going to put some numbers in there. It's going to be great. Okay, so the first thing we're going to do is we're just going to label our legs. We're going to do this guy will be 5. And this guy will be 6. Let's do this one too. This will be 6 and 8. And then this guy over here will be 5 and 12. Okay, we're going to start with this 6 and the 8 guy because I want to. So these are the 2 legs. Remember that the arrow always points to side C, and he's very important. The Pythagorean Theorem is a squared plus b squared equals c squared. So basically what it's talking about is the area. If you look on, okay, well, this one. So if I had side lengths like this, this is a 3, 4, 5 triangle. These side lengths make up my right angle. And this area of this is 9. And we know that this square's area, because it's 3 times 3, so the total of this area attached to this line is 9. The same thing here. This is a 4 by 4 box. It's a square. So the area of this square is 16. Then this side, the diagonal side, side C, our hypotenuse, has an area of 25. And I know that it's 25 because it has a side length of 5 and another side length of 5. The special property of the Pythagorean Theorem with right triangles is the smaller sides, the 2 legs areas, add together to make this hypotenuse area, which is 25. Okay, so the area of a little and an area of a little equals the area of the big. So area of the little and the area of the little equals the area of the big. Leg and leg area equals hypotenuse area. So that's the Pythagorean Theorem. Really quickly. Okay, and here it is written again. So we're going to be using this the whole unit for the next few weeks, so you'll get to love it. So we have our two sides, or our two legs, 6 and 8. So we're going to put them into our Pythagorean theorem and solve for our length of side C. So we want to figure out what the area of this missing box is right here. Okay, so we've got 6 squared and 8 squared equals C squared. So we're using our formula and plugging it in. Again, remember at the very beginning when I talked about A's and B's, then they don't matter which one is which. That's the same thing here. So it doesn't matter if you put the 6 in for the A or the 6 in for the B. It's the two little sides area that are right next to the right angle add up to be the big sides, our hypotenuses area. So 6 squared is 36, 8 squared is 64, and then we have our C squared. So then in our calculator, because we're just going to make sure we're doing it correctly, we're going to add our two little areas, so 36 and 64, and we have a total area of 100. So we have 100 is our big area for our hypotenuse. But we want to know the side length, so we want to know the root of this big area. So there is, pretending there's this big area of square, which would have boxes in here, and it has to equal 100. So we're trying to figure out how many boxes are across right here. So if we think a long time ago we talked about this. Oh no.
Teachers,
sorry.
Staff will be cleaning out the fridge
Great.
in the faculty room tomorrow. So if you have
I'm really sorry, guys.
you are wanting to keep, you need to grab it today.
Well, sometimes
Okay.
it's important to clean out the fridge.
We got to clean out the
Reminder.
fridge. Okay, no corona. All right, so now what we're going to do is we're trying to figure out the root of this side. So if we notice, we have a squared. So the opposite of squaring is square root. So we're going to figure out the square root of 100 to get our side C. So the square root of 100 is 10, which means that there would be like 10 little boxes coming across here. That's way too many. I'm really sorry. Anyways, our C is 10. Okay, so we're going to do a few more examples together, and then we're going to talk about some word problems really fast. Okay, so if my side lengths or my legs were 5 and 6, we're going to plug it into Pythagorean theorem with our two legs to get our C. Okay, so we're going to also write steps down just so that we can see what we're doing. So step 1, we need to figure out our C. So figure out C. Okay, then step 2, we're going to put sides into formula, MULA, and then 3, find area, 4, combine like terms, 5, subtract, and or add, I guess, yes, either. And then 6, we're going to find our root. That's tricky to see. I'm going to put another sticky note underneath. Sorry, guys. There. Nice and darker. Okay, so we're going to figure out side C. So side C is always directly across from this right angle. So this is side C. It's important to know because that's the guy that's on the outside. Okay, then we need to put our sides into our formula. So we have our sides of 5 and 6, our legs, so they go where A and B are. So we have 5 squared and 6 squared equals our C squared. Okay, the next thing we need to do are find the areas. Remember, these two legs make areas. So 5 squared is the area of this pretend square that you can't see. So 5 squared is 25, and 6 squared is 36. Make sure you're doing this with me. And then we're going to combine like terms. Oh, 25 and 36 are like terms because they don't have letters. So 25 and 36, I don't want to mess up, so I'm using my calculator, which is fine. You can always use it. Okay, so that's 61 equals our C squared. And then, so we combined our like terms. We added together. Sometimes you have to subtract. And then we need to figure out our root. So we have to take the square root of 61 because we want to know the side length of our side C. And we put it into our calculator. I think you can see it. Yeah, okay, so the square root, second x squared, second x squared, 61. And let's get that into decimals. So we have, then that you press the squiggly line above it. If you're using this kind of a calculator, there's other ways to do that for different calculators. So 7.8 equals our C. Okay, so that's the end of this video. We're going to do another video in just a second for the word problems.